Well, good morning, and thanks so much for joining me here in my shop on the 17th of February. So I think what I plan to do today basically is replace all the old capacitors in this radio and have it working by the end of today's session. And then tomorrow my plan would be to tune it up and be done with it. That's pretty optimistic. Let's see what happens here. So I think the first thing I want to do is install some new capacitors to replace the filter capacitors in the power supply. I just can't imagine that they're in good shape here. The thing about it is one of the two capacitors is insulated from the chassis. Yeah, I'm pretty sure if I leave this in place and just put the new capacitor right up here, that's one done. That's a 450 volt 16. Pretty darn crowded in there, boy. So I'm just looking to see if there's another grounded terminal closer. There's two terminals. What I'm worried about is that one of these two capacitors is the bypass capacitor for the output tube. I'm not really worried about it, I just like to know that. It's most likely this one, but this one's rating is way high. This isn't high, 16, but the voltage rating is crazy high. So, and we know it's hooked to the input filter. This one, that means there has to be another. That means if there is a bypass capacitor, there's probably another electrolytic capacitor in here. And this is just a three element power supply, but with a field coil. Generally, two capacitors do it. The third is the bypass. I don't know, it's not adding up here. Okay, so I think I know what I'm doing more or less. I'm going to take a peek at the schematic, then I'm going to install those capacitors, and then we're going to play this radio and see what happens. Okay, let's take a look at the schematic here, just the power supply at this point. So what's interesting about this radio is the technique they're using to deliver bias to the tubes. That's something done with the power supply. So if you look here at the power supply, we see the center tapped negative output, if you like, of this transformer, and after rectification, and the positive is going to be here on the. This one has a cathode in it, separate cathode in it. They've heavied up the B plus lines, so you can just follow this along. You can follow along where the B plus is going. You'll see it eventually gets to plates of different tubes. Now what's interesting is this part here. To understand this part, we need first to look at the cathodes of each tube. In this radio, you'll see every cathode is going right to the chassis. Every one of them is connected solidly to the chassis. Every one of them. And that's this connection. So you can think of the current as going out on the positive, coming back. You know, we're talking about current flow now, not electron flow. Just for those of you who were trained to think of current as flowing from positive to negative, that's kind of what I'm doing here. So the current is returning to the power supply from each of the tubes through these connections, right? The tube current flows through the tube, through the cathode. It's all in these connections, and they all tie back to here because ultimately that current needs to get back to its source, here. So the tube currents are flowing through these three resistors. They're reaching this point. So this point is just a wire to here. This is the most negative place in the radio, right here. And where does it go? They send the most negative voltage to the grid of the 6F6. This tube is looking for something like almost minus 20 volts for grid bias. Come back here, and then we follow this wire. Whoops, follow this one. This is a little less negative, traveling through, and now it's reaching, never mind that it's the detector plate. Never line? That it's going to the grids of these first tubes. Now this one doesn't exist in my, this whole piece here is missing in my radio, this whole thing here. We can't do much about it. I'm assuming the power supply is essentially done the same way. This last line here is going to this grid. So what's happening here, you can think of this as somewhat positive, and that's what's driving the current back this way. So all these cathodes are somewhat positive to the grid connections, and that's what you want. You want the cathode to be a little positive to the grid. We tend to think of the grid as being negative to the cathode. It's kind of the same thing, one way or the other. So this is all about biasing. Obviously, if there's trouble in these resistors, the biases would be off. And it's important to check. Certainly the bias on the output tube is very critical. No bypass capacitor? Well, hang on a sec. They might be bypassing all of this somehow with something. I don't know. I don't see one, but so maybe they're not bypassing any of this. Okay, so as usual, you look at the schematic, then you look at the radio, and man, it's hard to relate the schematic to this jumble of stuff in here. So I started with the down here. I know there's got to be a resistor connected. Hey, look what's right there. Now this resistor, you can kind of see, it starts with a red, and I don't know, could be brown, could be black, I don't know what's going on here. I measured this guy, he's 290. Okay, the schematic shows this resistor should be, I think it was 260. Maybe it was 240, I can't remember. It's a little high. Anyway, don't know what the colors are here. So this has got to be the first one. So this one should connect to the next one. So it'll be very hard to trace it, but the wire comes up through here, connects to here, and look at this lovely resistor just sticking out here. And this one should connect to another one, and sure enough, it connects to this one. So there's the three of them. 1, 2, 3, right? So it's like a 260, 40 ohms, and 16. Body and dot. Green, brown, yellow. Yellow is hundreds of thousands of ohms. What's going on? This one's the same. It's got a yellow dot, yellow band in the middle. Body and dot. More resistors in there. I couldn't find them anywhere. This radio's varying from the radio on the schematic. Yes, it's missing a tube. Would that affect these bias resistors? Well, maybe a little bit. Maybe, I don't know, I don't think so offhand, but maybe a little bit. A little bit would be, it's not going to be 40 ohms, it's going to be 50 ohms. Not 50,000 ohms. So I'm just interested in this because it's not adding up, and I'm always uncomfortable when things aren't adding up, which means I'm almost always uncomfortable. That's what it really means. Back to doing the capacitors. I figured one was going to go basically up here, and the other two I hadn't really figured out exactly, but it was going to be something like from the terminal to this ground terminal here. I gotta dig up my capacitors now, get a nice set of them. Okay, so that's what I've got here. This is 16. This is 15 at 400 volts. This is 4.7 or 5 at 400 volts. Pretty small. And this one is 8.2 at 400 volts. Well, this guy should do the trick. And we'll get them installed. Okay, so I'm just making the last connection. The last capacitor. Last look here. Make sure everything's solid. Okay, we're going to try to operate the radio again. Maybe I can get smoke to come out of it this time. So I'm going to put a new cord on the radio at this point, and I just want to look at the schematic. I've going to put in a polarized cord, and I want the hot wire to be leading to the switch here. So we've had lots of snow here in Aurelia the last couple days. I shouldn't talk too much about it because I know people all over North America are swimming in snow. I got about 2.5 feet of snow on my yard at this point. That's pretty typical for where I live in the winter here. The total annual snowfall in Aurelia is typically 9 feet, but you know, it comes and goes. So just a year or two before I moved to Aurelia, they had all those 9 feet at once. And it's quite a deal here, but it hasn't happened since I've lived here. It's just been actually pretty normal. Lots of snow coming in the next few days, though. It might be a little different. So we have the cord in. We give it the test. It's, you know, it's not really going to go anywhere. After all, the radio's not being dragged all over somebody's house every day. It's hardly a portable radio. Those are good. Okay, that's good. Now we can plug it in. Now we can plug it in and really get the smoke coming out of it. And this is the band change. The band change. Mysterious three position 4-band radio. Okay, so that's probably broadcast band. I'm sure one of these bands is probably, let's see, 2 to 5 megahertz, 6 to 17, 17 to 49, and the AM band. That's 4 bands. That switch only does 3. Let's get a little muscular on the switch here. Wow. Band 1, band 2. What happened to now it's down to 2. Only 2 positions now. 3. That really feels like the end of the road. How does that work? How do you get... This is in meters. 49, 45, 37, 31, 25, 18, and 17 meters. Let's see, the 19 meter band is 15 megahertz. Yeah, so that's what's happened. So this is 3 bands. This is the same band. They're showing it frequency and meters. Okay. I knew it had to be something like that. Now, one of the things when you're doing these radios is you go along, you discover and learn more about them, even as you're in the middle of working on them. And am I hesitating for some reason? Not really, no. Off. So we're checking to make sure this off switch goes off. We need some voltage here. So we'll start with roughly half voltage. I'm going to put it through the dim bulb because I'm just that concerned. Worked on the power supply as much as I tried not to make a mistake. I may have. So we're all set. If something bad happens, this light will come on and stay on very bright, and that will keep from something bad happening. Tubes are in, everything's ready. No reason to hesitate any further. Okay, so this is just the test of the switch being off, to make sure the off switch does turn it off. So we have all of 80 volts reaching the radio, but it's obviously not reaching the radio. So we're going to switch it on at 80 volts. Okay, you see the dim bulb come on. It's not on bright at all. It's going duller. It's going duller. Very, very little voltage now reaching the radio because of that light bulb. So we're going to turn it up a little bit. Okay, got, well, this says 39, but I don't think it's correct. So Well, maybe it is 40. It's next to nothing. So the radio's trying to draw a fair bit, I guess, through this light. That doesn't make sense either, because the light would be quite bright. Why is this only 44? Well, maybe it's indicating something's wrong here. Now, there's only one tube I can look in. That's this one, to see if the heater's going. I don't have the warm and fuzzy feeling at this point. I have a concerned feeling. This fuse is still out here where you can get a shock off it easy. I'm looking to see if there's any glow in the tubes here. I don't see anything. Son of a gun. Okay, we'll take it a little higher here. Oh, I've got my phone in my pocket again. Shame on me. Okay, so I apologize if you've been listening to my cell phone click and pop during the video here. I hear a hum. The light's pretty bright now. Oh. 47, 46. So what I'm going to do is I'm going to turn this down a little bit. I'm going to interrupt the power briefly and try to reset this. I think this guy is confused. Power off, power back on. Boy, did you hear that thing hum there? He's not confused. Have I got it on watts or something? Volts. 45 volts. Something's not right. This is humming like crazy. Well, not like crazy, but oh my gosh, the field coil's loose in the speaker. Hey, what's happening? Not having the warm and fuzzy feeling at all. How many watts is this thing drawing? 6 watts. According to this, it's 0.15 amps. That's making an interesting comparison here. 15 amps, eh? That'd be full scale here. What did I read here? Amps. Point 1, not 0.1. So we're 0.1. Wow, we can't really read it on the scale here. It's too low. Nothing, no big deal here. That's the voltage again. I can't believe that there's 80 volts dropping on this thing right now. What we'll do is I'll screw in another light in the dim bulb. That's going to throw a lot more power at the radio. This thing's going to start humming like crazy, and I'm going to panic. That's what's going to happen here. Why is this thing humming? Okay, my feet have gotten so cold I'm going to stop here. This is not going the way I thought it would. Lots of capacitors in there to change yet, but the hum shouldn't persist after doing the filter, the power supply filter. Time to stop and think. Yeah, stop and think. I never cut away the old capacitors. I did one, but I didn't do the other one. I got ready to do it, and I don't know what I did. Let's try it again. Here. Okay, so radio's unplugged, no power in it. So I'm guessing the result was because these tired old capacitor is still connected. Now I got to cut the lugs off. I was about to explain this. I've utilized the lugs for the new connections because the wires coming to them can't be moved anywhere. So the idea is you hook up to the lugs where they are and then cut them free. There's a couple other ways of doing this. You can put lug extensions on, and there are various ways to do this, but ultimately we got to get it off the capacitor here. Okay, ready for another try. Now, my experience with these capacitors is you can leave them in the circuit if you wish. They aren't doing much of anything, but maybe that's not really the case. Maybe maybe in the case of this radio, the capacitors are extremely leaky. You know, I haven't bothered testing them or anything like that. Okay, we're almost ready to go here. Plug it back in. We'll start off just a little lower. We're on back to one light. That's still safe, and some tools to put away here. Okay. Okay, let's get around the front. Switches off to start again. Here we go. Okay, now. So this says 90 volts because there's no current flowing and there's nothing dropping on that light. This probably says 90 volts. All 90 are here. As soon as I turn the radio on, though, that 90 will drop because some of the voltage is going to be on this light. Let's turn it on. Anybody see me jump back? I actually jumped back when I turned it on. So what are we getting here? We're getting 40, same very low voltage here. Let's see if we get the same hum out of there. 40 volts. Wow, that's really low. But nothing is bad. Nothing bad is happening. Let's crank it up here. 77, 78, up around 80 volts now. That should be enough. Seem to be operating completely different than last time. Don't really like that either. Oh, still coming. It takes a long time to heat up the heaters when you're operating on low voltage. If this is the volume, it's not doing much. 82 volts, we don't hear any radio action. How do I know the B plus is really going through this radio now? Okay, that's gotta be as... We'll try is a little more voltage on the radio. Here, I'm sending over 80. Oh, that's good. I'm sending over 90, and 80 is making it. There's almost nothing dropping here. Okay, let's go a little higher. Usually I find radios work 90 volts and above. So we're getting up close to 100. Volume up. Okay, now we're going to inject a few signals here and there. First, audio amp. Nothing. This is the audio preamp. It goes into the audio tube, comes out the speaker. We should hear that. Can't hear that. Can't hear any of these either. Possible problems. B plus not going through the radio. That's highly likely. Let's shut it. Let's I don't want. Let's turn it off. While I stand it up here. Let's turn it off. Yes. Everybody, reach for your off switches. My voltmeter. Stick one on the chassis. Now I better use a click lead. Make a more certain connection. Red to the chassis. Okay, we'll put the power back on. Look away, look away. You know what is really suspicious here? The lights aren't coming on. Yeah. You could take that in more than one way. The lights are not coming on. That almost suggests the fuse blew. How would this hum? Okay, let's start with, there has to be some voltage in this radio. We're ready to do DC B+. We would find that on the positive lead of those capacitors I installed, like this one. And it looks like a big fat 0 to me. Okay, so maybe right off the rectifier. Okay, so there is the voltage. How about I touch this lead here? So this is the first capacitor. Got lots of voltage there. First capacitor. Let's try that again. That's better. Ooh, 413 volts. I put 400 volt capacitors in there. Woohoo! Take it down a little bit. Of course, the ratings on capacitors aren't that precise. So when they say they're good for 400, they're probably good for 800 for quite a while. Well, maybe not 800. What's happened here? It looks like the B+ is just not making it into the radio. Oh. Huh. Did I misinterpret something? I did. So, this wire, which you can't see in the dark, I can barely see it myself. This is the problem. I didn't look close enough. So this wire comes up and just goes into the transformer. It connects to the ungrounded outside of the old capacitor. My eye followed this up and got onto this wire. And I convinced myself, because of the way they are, is because the real wire turns black here. It changes color. It goes kind of an orangey color here, and it turns black here. So I just followed the wrong one. That means I put that capacitor. When I thought I was connecting it here, well, I've connected it to who knows where. Big boo-boo. I need to either move the capacitor from where I stuck it way up here, or bring a lead down and pick up this, which is probably easier to do. Bring a lead down to here, bring a wire up, catch this capacitor properly. Didn't I say something? As hard as I tried to not make a mistake, I still managed to find ways to do it. There's one right way, or maybe 2 or 3 right ways of doing this, and about 50,000 wrong ways staring at you. Okay, I'm going to sort that out then. Okay, let's see what happens now. It's a good thing for me. I'm well practiced at finding my mistakes. Oh, here's one. I think I've turned this over the same way 2 or 3 times now. I'm kind of wrapping up the wires. What's going on there? Oh. There we go. Yeah, it's all tightened up. Yeah, bit of a mess there. Sort that out later. There, have a new perspective on life. Let's see what happens here. We did the power supply stuff again, so we're going to start from scratch. Power off. The meter out of here. Okay, we'll start out a little bit lower. Right, switch is off. Power on. 86 volts showing up. 86 volts dialed up. Nothing going to the radio. Let's put it up a little bit higher, I think. Let's be bold. Be bold. Let's give it a shot here. Now I got 2 dim bulbs in, so this isn't going to drop much. 100 volts. Shouldn't drop much. Okay, maybe it'll come back up. Okay, let's listen. Still listening. So we're at 90 volts. Let's just go a little higher here. There's 100 volts. Sure is quiet now. That's another unreassuring thing. Turn off my soldering iron. Here. Volume up. Nothing. You know what? Those lights are not on. I thought one of the lights came on the first time I ran this. Maybe I'm mistaken about that. No sound now. Is that better? You know what? I think that's better. Look for B plus again. Let's do that. I'm going to rotate the radio the same way, so I'm going to have to unrotate it. That's a partial unrotation there. Okay, I wonder what mistakes I've made now. Get the meter out here. May not be any mistakes. It could be, of course, the other tired capacitors are the factor now. But usually at this point, most radios start talking a little bit. Do again, voltage to chassis. So we know now from looking at the power supply that reading the voltage to the chassis shows you a little more than what's actually. That's not even a fair statement, is it? I won't finish that one. Okay, let's put this over here. Okay, we're going to power on again. So we're interested in this point here. Jeez, the speaker just clicked. Why would that happen? Is something loose here? Did I shorted something. Yeah. Voltage 0. Voltage 9 volts. I think maybe I've got another error in here, which is what? Shouldn't it really be there? I think I've hooked up. No, I think I've hooked up this capacitor to the wrong terminal. Well, I made 2 mistakes doing this. How can that be? 424 big volts there. So hooking this capacitor up to the wrong spot shouldn't have quieted the radio. It should be operating because there's the voltage. And what about up here? How about you? You don't have anything. Well, you're not going to work well without something. What about here? How about here? Anybody? Somebody? Anybody? That looks like a big screen resistor. You really can't see the meter, can you? It's nothing. It's just zeros. So nothing. You're not missing anything. No P plus getting through. Jimbo. Not a good sign. Okay, so there's two. There's maybe this is quiet now. There's no current in it. Not getting more. This would take a long time to heat up anyway. Look at the amount of metal in it. So, 2 high voltage filter capacitors. One here. That's the second one. And the first one, which I think is in the wrong spot now, because I've got it on this terminal, and this is the guy who's got the voltage. .400 volts of B+, that's really high for a little radio like this. It's probably because there's no current draw in the tubes through the power supply, so you got basically open circuit voltage, which has risen up above what I would have expected. Well, I just have to look at it very closely and try to figure out why the B+ isn't making it through this radio. Perhaps when I soldered one of the terminals, sometimes when you solder to a terminal you don't see it, but you've released another wire that's out of sight. It's fallen off the terminal. I just doubt it so much. Okay. I'll just go looking here. And I'm looking this over now, and it looks like I made a mistake everywhere. So you see, when I'm aiming this camera at, we're going to look at the bottom of the 2-terminal capacitor, or at least what's left of it, because I've cut off the lower terminal. You can kind of see where it was. Just out of view is the upper terminal. Look, they're the same terminal. It's the same piece of metal. So that big post is the post coming out of the capacitor, and then it has a ring kind of fixed to it there somehow, and then the ring has the 2 terminals. One I've cut off that's missing, and the other one is underneath these wires. You can kind of see what's left of it. Wait a minute. That upper terminal. Is it really connected? You know, I'm going to take this capacitor, I can get at it this way. I can take it out of the radio and really look at it. Well, yeah, I'm sure it's the same piece of metal. And then just below the circular plate that's looks like it's literally been pushed onto the post, is a little bit of an insulator, and then you have the outside, which is the negative. This is a single capacitor, not a double capacitor. Boy, did I ever interpret that totally wrong. Okay, I have to rethink everything I've done here, because I think I really I really boobed this up badly. Yeah, and maybe it's time for lunch. Fuel up. One of the problems here is the capacitor in question. Does it have 2 terminals? Does it have 1? The capacitor is the one with no label on it. So if it had labeling on it, well, then I would know. I'm going to try to take it out, because I want to take a look at this guy. Maybe I doesn't want to turn. I'm supposed to get a tool way up in there. Turn that. Loosen. No, it won't turn. I'm sure of what I'm seeing under here. It's a single terminal. Single terminal. 2 capacitors here, but on the schematic there's 3. I managed to stick 3 in because of the 2 terminals, the no label, and the schematic tell me to stick in 3. There shouldn't be 3, maybe. In this radio, maybe only 2. 2. So what's this one doing then? This wire, this is the problem. This wire is not going where it needs to go. So this wire used to be on the capacitor terminal. The capacitor here is now here. Really? You know what happens here? I think I got it. And then I go, no, I don't. I don't have it. I got nothing. Okay, I think I understand my mistake fully now. So, thinking this capacitor had 2 terminals, I installed 2 more capacitors and just hooked them up to the positive terminal locations of the single capacitor. So now I have an extra capacitor. I'm making a mistake already. And then cut away the terminal. This is the cleaned up cutaway wire from here. But this wire really should be connected to the positive side of this capacitor. If I run a wire from here up to here, I will then connect it in properly, and I'll have this capacitor still connected. These two will be in parallel. They're going to add 4 and 8. It's going to be 12. 12 when it's looking for around 8. I don't see a problem with that. I think simple thing, just run a wire from here up to the positive side of here, and everything should work. Probably just making another mistake, but for now, sounds great. I'm going to do it. Okay, I think I'm ready for another attempt. So I've installed this wire. Yeah. Oh. Yeah, it didn't solder. Didn't solder. How do you like that? Okay, have not installed that wire. Okay, we're ready now. This time, I'm very unsure about having done the right thing here, just because there's just been too much confusion running around in here. So I'm going to go through the dim bulbs and start with one dim bulb and low supply voltage. We're on. Very little current. Good. Now, this voltage, I can't imagine the rectifier is going to do anything. Let's just find out. So we get on the positive of one of my multitude of capacitors in here. I'll go up here. Okay, nobody's home yet. Is this really connected? Yep. Okay, I'll go up a little bit. Yeah, it's starting. Whoop. Nope. 64 volts. Looks like it's trying hard. Go a little higher. Okay, so at the radio now, 75 volts. Current flow. This meter went backwards. What does that mean? How does that meter go backwards? That one? Nothing. Nothing there. I don't know what's going on there. Not an instrument I'm not familiar with yet. I still have no B plus showing up. Is it because I don't have the radio switched on? Is that possible? Yes, that is possible. Okay, back down. Great test, Jim. Okay, and we're going to switch on with dim bulbs. And here we go. Okay, look at the current. And this time it's going up, but it's not much. It's good. A little more voltage. Oh, I got my phone in my pocket again. Oh my God. Okay, we see any voltage showing up yet? Well, the dim bulb is actually glowing. I don't know if you can see the element here, but so there's definitely power going in here now. Isn't that scary? So we're still at 39, only 39 volts. Let's go up. We gotta go up. We gotta go way up. I cranked that one up, but this didn't go up. How is that explained? Anything showing up yet? B plus wise. Still seeing nothing. How about some other capacitors? What about this wire down here? Oh, 3 volts. 4 volts. It's coming. Same wire up here. Okay, it's coming. Finally. We're getting there. So the concern here is as the rectifier begins to conduct, it conducts into a short circuit. So I'm watching the current flow over yonder. Well, we're getting up there, eh? 90, 100. It's getting there. According to this, we're still running with 40 volts. Is that even possible? Yeah. Let's crank it up. We're still losing voltage on the dim bulb. You know what we'll do? We'll crank it down and we'll bring in this other bulb and reduce the dimming. 74 volts. 73. 74. And the current still way down there. I think we're good. Don't think I made a mistake here. B plus would now be, is it getting up around 400 still? 324. Okay, let's see if the radio is working. It would appear to be not the case. Stomach's working. Right, that's my stomach growling in case you're hearing some funny rumbling. She's a 0 still. Okay, get B plus up in the radio itself. How about up here? There's still nothing. Oh, come on. How can there be nothing? Looks like it should be here. Looks like it should be here. Or here. Oh, I still haven't done this right. It still isn't right. It's still not right, Jim. Lunchtime, for sure. Okay, I think I got it out. Got it sorted out. I had to draw a diagram of what's in the radio there as best I could. Compare it to the schematic, recognizing that there's no B plus voltage getting up into the rest of the radio. And I discovered that I'd made a very simple error in this wire I put in. I soldered to the wrong terminal. So this is going to feed the screens in the radio. Now it's hooked up to the correct terminal. So that's all it was. Luckily, nothing bad seems to have happened. Just a little damage to the ego. You know, there's not much left of my ego anyway, so it doesn't matter. We're going to give it another try. Okay. These guys are all okay. Oh, I tipped it down, so, well, it's down. We'll leave it down. Power switched off. Okay, so the radio's on but turned low. And we're going to feed through one light to start. Power supply stuff I did again. Everything ready, and the actual supply voltage is low also, so we're low, 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 low. Nothing special happening there. Guy here is messed up. I'm just going to raise this a wee bit. Interrupt this briefly and back on again. There we are. Very low. 39 volts. Here we go again. Very, very, very low. Okay, so we'll go to the second bulb. 78. Turn the volume up. Double Check the current. Apologize for, I realize how noisy all this is. But things like that happen, it's really, really noisy on the. So no problem here. I'll just go back to the voltage again. Okay, radio, it's up to you now. No answer comes the reply. Let's give him a little more juice. He's only 67 here. That's really, oh, this guy's really drawing the just a little surprised that that light is on like that. Let's go a little higher. Lots of radios operate, these lights glow a little bit. Come on, radio. More volume. It's really pretty quiet. Now, there's no reason to think for sure the radio is going to come on. There's other defects that could be in here, but I would sure hope it would. Okay, a little signal injection. I'll turn the volume down, up a little bit, up a little more. You can hear it. Up a lot more. Certainly sounds like a weak output tube. Now, could that tube be so weak that the signal's coming through here and we just can't hear it? Let's find out. I'm going to turn on a device over here called the signal tracer. This guy has his own hum. You'll hear a hum come up. So not to confuse it with the radio. Okay, now you might also hear a little bit of music coming in here from next door. We'll just see. Look out. Radio's on. Right, I was just about to make this measurement. Right. So if we see something like 30, 40, 60, 70, we should not be too worried. If you saw 120 there, that would be a little bit scary. Then we would worry. Should be able to connect this. Stand back. Where to? Where's a good connection spot here? Maybe right in here. Okay. What we'll do is we're going to listen to each of these grids. Try to hear what's on them. So first one is first one's the it's got 3 stages. Okay. First tube, got to be this guy. We're looking for an antenna type signal there. We better put an antenna type antenna on here on the radio at this point. Okay, second ground coming on, but it's the same ground. So what has it on here? We'll do this and we'll do this. This goes to an outdoor antenna, but it's not turned on, but this will provide some antenna action itself. Did the radio come to life when I did that? No, of course not. Okay, volume doesn't matter. Now, we're going to try to pick up actual radio station there. So you want to change the settings on the tracer, which can trace either audio or it can trace RF too, radio frequency stuff. RF, and we're trying to pick up an actual station that's on band B. This is now an irregular radio. some strange stuff. That's coming out of my finger. Oh, I should go to the doctor or something. Holy smokes. Now, we're probably not going to actually tune in a station here. But let's just see what happens. This is basically like right off the antenna practically. So I don't know what kind of fanciness we're going to get here. This is maybe not the best place to start. Tune the radio and see what happens on this. So tune this to 900, about the middle of the band. Tune this. This is a real long shot, by the way. Not as long as I thought. We're at 900 now on the dial here. So 900 is coming through. There's just no station at 900. This tube will convert it based on the local oscillator. Ooh, turn it down. Based on a local oscillator, it should be converting it, and this tube grid should have 455 kilohertz on it. So we're going to switch now to a different band here. 455 kilohertz right up here. Okay. What are we going to hear here? We should hear something similar to what we heard over there. And yep. So the radio's actually working to this point. And if we tune this radio, we might actually tune something in, if by some wild chance. So radio, a lot of dirt in here, making all that crackling stuff. Turn it down a little bit. Okay, so we're coming around to where there could be a station. Ooh. So now that's a typical noise I hear in my shop. Working through this tube and up to this tube. It's probably working past this tube. Gets past this tube, goes through this transformer, makes a wild jump over to this little tube. Gets converted kind of into audio. This little tiny tube here. The audio is then sent back on this wire. So if that's happening, this wire has audio on it. Now I'll change my signal tracer again to audio. Okay, so now it's just an audio amplifier. Is there any audio here? No, probably not. Who knows, right? Let's see. Okay, now that sound that's coming from next door. That's not coming out of this radio. Let me be clear. The music you hear, I'm sure you can hear it. Pounding away. What's coming out of this radio is this. Ooh, a little bit of feedback there. Am I making contact? I think we would have heard something by now. Some audio. So what it suggests here is the radio is working fairly well through here. You could guess through this transformer. Then somewhere between here and here, which is basically there, things go downhill. Isn't that the one tube I didn't bother testing? Yes, it is the one tube you didn't bother testing. Inky dinky, inky dinky, inky dinky. What kind of house? That's right, children. Schnitzel. Okay, after an awful lot of studying and looking at this thing, I'm really scratching my head now. So on the schematic in the power supply, there's a series of 3 resistors, all low value resistors. One of them is at 260, I think, and the other one's 55 or 64 or something like that. So the first resistor would be this one. This is in the right position. It's connected to the right place. It's roughly the right value. I can't read it. It's really old. I can't read it. but it measures 290. I think it's supposed to be 260, something like that. And this is connected in series to this resistor, this green one, if you can see it. And this one would look to be connected in series with this one. Oh, there's the three of them. Boom, boom, boom. Okay, from there everything goes downhill really quick. This is a ground terminal here, so if things end here, so what this amounts to is this resistor is connected in series with this resistor. They're using a spare terminal on this tube. It's the only thing on those terminals. This resistor and this one. This one's value is 290. This one's value is 350,000. Why do you put a 290 in series with 350,000? You don't. Why does this resistor look so old and beat up? But this looks shiny and new. This looks shiny and new too. So all those questions are rolling around in my head. I've really got my hands full here. Something is terribly wrong somewhere. Either they're really in the danger zone here. I've got a schematic that may not match in a radio that somebody's done something to it. That's what it looks like. And I'm in the middle of doing something to it. This is really the place you don't want to be in doing this kind of stuff. So I think I'm going to call it quits here for today. Too bad. I'm really anxious to get the radio to operate. Pretty close. Kind of have an idea where the problem is, but there's just too many other factors here. I'm going to spend a little more time today looking this thing over and see if I can't make a breakthrough of some sort. Thanks for watching to now.